読み直している。で読み直している。だけがで読み直して。
All right. Hi, everyone. It's nice to see you all. Well, kind of see you, not quite see you, unless you want to be infected. It's good to be back. I was trolling a little bit with that beautiful poll. Flex week is not really a break. It's when you catch up on everything, but at least you don't have to be anywhere or learn anything new, and you get to sleep in. So, yay! Um, I hope you enjoyed Jake's lecture yesterday. Sorry about that. I found out about 10 p.m. that I might be a bit infectious, so he was, yep, just he got a call that he needs to go in and do it. And I guess I'll be taking him to Uni of Sydney for a thank you lunch because he seems to think that that's his favorite place. I think you've all heard that. So amazing. All right. So how is everyone going? I feel like it's been forever. I hope everyone is going well. I hope everyone is ready for this lecture, which is, I feel so bad about this lecture. I feel like I come back and I'm about to give you this lecture, which is going to be about memory and pointers, and it's going to be like a real fry up. I'm going to cook you all before Flex Week because I want you to I want you to be able to use all that free time you have during Flex Week to reflect on memory and pointers, so that, and then don't worry, because when we come back we're going to kind of rehash everything and go over everything again, but at least it's like a nice introduction and something to think about. But as usual, I've gone insane and prepared way too much stuff for this lecture, so don't worry, whatever we don't get through today, we will cover when we come back. Plot twist, he is never going to University of Sydney. I am not letting him. Absolutely not. Okay, let's begin. Today we're going to be pointers and memory. Today you're going to be in for an absolute treat. And yeah, and I'm in there with you for that treat. Okay. Okay, so I guess you can't see what I wrote there, but for those of you interested, I did eat a lot of churros, and I thought I was going to have to, roll back into Sydney, but luckily I couldn't eat for about 4 days because of what I had, so I'm back to being able to eat churros, which is one of my favorite things to eat. Okay, so today I'm going to attempt multi-file projects if we have time at the end. And if not, it's going to be the first thing that we do in week 7. Other than that, pointers, a bit of memory. I was going to do some dynamic memory allocation. Then I decided it's all too much. So then I removed it. But who knows where the day takes us. We might be doing reallocation of memory. But, let's maybe not. We'll see. We'll see where the day takes us. We'll see how it's all going. Okay. Lecture code, but I think Bree's already shared the link. Thank you so much, Bree. And let's talk about pointers. I should have done a poll, but who has heard of pointers before? Yesterday, Jake said you'll be doing them in 2 weeks, and I was laughing because you are not doing them in 2 weeks. You're doing them today. And you saw when you were doing command line arguments, that little star is about to make sense. That little ampersand in front of scanf is about to make sense also. Make sense, like it's about to be explained. I don't know if it's going to make sense yet. The thing about pointers is you'll listen to what I have to say today. It will make sense. You'll be like, yeah, okay, that makes sense. And then you'll go to use pointers and they will be just really super confusing. And the best way to kind of get into them is to keep using them and to get used to using them. So people are really traumatized by them. Don't be traumatized. Just know that it's like they make sense, and then when you try to do them, nothing makes sense, but then it slowly starts to make sense. But pointers are actually one of the reasons that we do see at UNSW. Obviously, if you heard Jake yesterday, it's also to one up on you, Sid, but that's beyond the point. No, it's not. It's so that we can teach you pointers, and so that we can talk about memory, and so that you can actually get a good feel for memory in the computer. And once you learn C, and once you understand memory, it does make every other language so much easier to learn, where a lot of this is usually abstracted away from you. So all out in the open, and we're gonna talk about this stuff today. So why is it nothing to worry about? Because a pointer is just another variable. I am also blocking the slide with my, I thought I was so clever doing that circle. That circle surely is going to be magical. You know what? Doesn't matter, because I'm going to type it out, and then I'm gonna move myself in a second. No, should I move it to the right? That would probably be a good idea. Let me move it a little bit. Now, where did I put OBS? It's right in front of me. That's why I couldn't find it. That's clever. Very clever. Okay. Amazing. Okay, so let me put the chat on the front so I can see the chat. Okay, so pointers. The easiest way to think about pointers, it's just another variable, right? It's nothing special. People make such a big deal of them, and it makes it like quite scary, and it builds it up. So a pointer is just another variable, but what a pointer stores is a memory address. It doesn't store a number or a letter or a string. It stores a memory address where something else is located. It is a super powerful thing to have, because it gives us the ability to modify something directly in memory where it is actually sitting, right? So we're not making, when we pass something to a function, we make a copy of it in the function, and then we modify it there, and then we'll return something. So that uses up a bit of extra space, and also makes things inefficient, depends what we're trying to achieve. But pointers help us to avoid that as well, because we can modify something directly at the address. So how do we declare a pointer? And this is when you get to start using that beautiful star. To declare a pointer, you basically say what kind of data type it's pointing to, and then you do a little star and the name of the variable. Beautifully named. That would pass the style guide here. So for example, if the pointer is pointing to an int, right, then to declare it, we would say int and then star pointer, where pointer is the name of this pointer that I've just made. Okay, now this star over here is saying that it's going to point to a memory address, and that if you go to that memory address, it's going to have an int in it. So that was a really confusing, I feel like, explanation. It will make sense, I promise. I've got so many diagrams, and we're going to draw it up. Okay. What a great question someone just asked. Are arrays pointers by default? And I have a whole slide to cover that. Arrays decay to a pointer, and I have some code to show you how, and hopefully I have time to use that code, but that's a fantastic question. So an array decays to a pointer in C. Okay, so let's say I have a variable, and the variable is just our normal variable. It's of type int, and assign a number 2 to it. Okay, and usually what that means is I grab a piece of memory, and then on the stack, and I've got my variable, and it's assigned the number 2, right? Now, if I want a pointer now to point to the memory address of this variable, then what I do is I have an int star pointer, and to assign it the address where that variable is sitting. Remember when I said when we use scanf to start with, probably don't, I'm surprised you even remember who I am at this point in time, but I said, okay, when we use scanf, don't worry about that ampersand, it means address off, but you don't have to actually know what it's doing. Just trust me. There was a lot of trust in that week one. So that ampersand means address of, and this is saying we're pointing to the address of number. So the variable is number, the address of number, which means it's pointing to this thing. Oh, that was super successful. It's pointing to the address where this variable is sitting, which is right here. So that means that now if I were to print those two out, its number would not be 13, it would be 2, but the number pointer would be whatever the address is that it's sitting at. Okay, so there is 3 things that we want to know about pointers. Sorry, my God. So I've got bacterial tonsillitis, which is why I'm struggling to speak. Sorry, give me a second. Okay. So we declare a pointer with that star, and that star is where we specify what type the pointer points to. So if it stores an address of an int, then it's going to be an int star and then whatever the name is of that pointer that you want. If you want to initialize a pointer and assign it the address of the variable, that's where we use the ampersand, and that's where we use that and then number. And then we also would like to do something called dereference a pointer, right? And that's the moment where we want to access whatever is stored in that pointer, right? So what that dereferencing means is go to the address stored in that pointer and tell me what is there, okay? So to dereference a pointer, and don't worry, we're going to do all of this in code and go over it again. I think it's a lot more clear sometimes when you can see it actually happening. To dereference, you dereference with a star, and that means go to this place, find out what's there, and bring it back to me. So, okay, so maybe let's do it. Let's do it. Let's do a bit of coding, okay? Because it's too much talking. We need to do some coding, okay? And then that will help us to understand what's going on. Okay, so also someone says you can pass arguments by references is similar to pointers, kind of similar in that it's still making a copy, but because it's modifying it directly at the address, it doesn't really matter. It's modifying the exact place where we're actually doing something. So it's kind of the same, but just keep in mind of it's still making a copy, but because it's the copy is an address, it doesn't matter. It's still modifying things at the exact address that we want it to be at. Okay, so let's do it. Okay, so your first forays into your first forays into the lovely pointers. Okay, so first of all, let's make a normal variable. Okay, why not? We know how to do these, and let's do an int just because why not? We can try it with other ones as well if you feel like it. So I'm gonna int my variable, I don't know, 5. Okay, so int my variable is equal to 5. Okay, great. So we have a variable, we've declared it, it's called my variable, and it's initialized to be the value of 5. Great. Now I'm going to have a pointer, and I want that pointer, so I'm going to declare a pointer and assign the address of my variable to it. So I know that I want my pointer to store in the address of an int, right? So it's going to be an int star, and I'm going to call it my pointer, and I'm going to assign it the address where my variable is sitting. Okay, so I'm going to print out some things now so that you can see where it's all going, right? So the first printf statement is going to have my pointer variable, my variable, what's it called? I've called them something different. I'm going to change it so that it's all the same. Okay. So the first printf is going to tell us this pointer variable, my pointer has value. Now you'll see this %p and you'll be like, what is %p? What on earth is she talking about? what is happening. So %p is a format specifier that prints out a pointer address, okay? So it's a special one to print out an address. You will not really need to use it in 1511. I'm using it to demonstrate the fact that it's going to have an address, okay? And then I'll demonstrate something else as well with it. Okay, now the pointer is going to have its own address, and then it's going to be pointing to another variable. So let's run the program. We'll see what it does, and then I'll show you what I mean. Okay, and I am going to start drawing soon as well. What am I doing? I haven't compiled. That's always helpful. Where have I forgotten something? On line 19. Oh, of course, I've forgotten to tell it what on earth to put in there. Okay, that's for us to figure out, I guess. That's why. Okay, so the first one, the pointer variable, my pointer has value blah. What should go in there? What do you think is going to be in there to replace the format specifier? Will it be my variable? Will it be my variable? Will it be my pointer, or will it be something else? Yeah, okay. So the first one is my pointer. Good. Okay. Then the next one, the pointer has its own address, right? So the pointer stores an address, but it also has its own address. So how do I get the address of the pointer? What do you think I would do? And I want the address of this my pointer. How would I get the address of my pointer? And they're not the second. And then they're not the same. That's right. Someone's done. I just use an ampersand. And it's pointing to the variable, my variable, which has a value. So what I'm going to do now is, instead of using, I could just put in my variable here, right? And it's going to give us exactly what we want. But what I want you to see is also, if I use a pointer to do the same thing, I can dereference my pointer. And what that will do is it will say, okay, what's sitting inside my pointer? Inside my pointer is the address of my variable. And then that star says, can you please go to that address and find out what's sitting in it? So the star will go to this address where my variable is sitting, and it'll see a 5 in there, and it'll be like, oh, there's a 5 in there. So it will print out 5 as well. Okay. So let's have a look what it does now that I've actually filled in the blanks, and we compile. So now let's run it. That was a mistake. I don't remember what I've called. No, I think I was good. I called it the same thing. Okay. So let's have a look. So the pointer variable, my pointer, it has the value that in that. Okay. So this address, okay, is where this variable is sitting, okay? That's the address of my variable. Now, the address of this variable is sitting somewhere else. It's sitting over here. Note, they're not the same, okay? So the address inside the pointer, that's just whatever it's storing. And it's pointing to the variable, my variable, which has the value 5. So I did that first just using the normal variable. And then I did it by dereferencing a pointer, which says, what's the address stored in here? Go to that address and find out what is sitting in that address. Now, what do you think happens when I run this again? Do you think these addresses will all be the same when I run this again? What do you guys reckon? Three people? Anyone else? Take a guess. It's 50-50. Yes or no? Maybe. I love that. Let's sit on the fence. Oh, a few yeses, a few nos, a few maybes. Yesn't. Okay. That's just really sitting on the fence. I don't know. That's a really nice one. And quite possibly. Okay. So... Someone said, what do their address numbers mean? Their address number is just their address in memory, okay? And it's just a hexadecimal value where it's stored in memory. You don't have to understand it yet. That's what 1521 is for. That's what you're moving on from 1511 to do. So I think it's a mixed bag. Some people think yes, some people think no, which kind of leads me to think, how much did you remember from like scope of your variables and stuff? Scope of your variables. Who remembers scope of variables? What happens when they reach over here? When they reach the closing brace, we kill off all of this, okay? We free up the memory again. So when I run this program again, it is very, 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 very unlikely that they're going to have the same addresses. Of course, there is some sort of fluke chance that it's going to shove them into the same places, but it would be highly unlikely. And I mean, if it were to happen, I'd run out and buy a lottery ticket, to be honest. Okay, so it's given them a different address, and that was just me trying to kind of bring in another thing of like scope of your variable. So remember, when the curly braces close, whatever was living dies, and we're going to do a little demo of that today as well, just so that you remember how variables live and die as well. Okay, so now there were some questions in the chat. Let's answer them off. Let's difference between the ampersand and the star. Oh, someone's answering. John's answering it. Students are answering. Amazing. Thank you. I've got penicillin is the world's greatest invention at this point for me. This is the first time I've been out of bed. Okay, so let's do it. That was amazing. How actually just from that very first first 20 minutes off pointers, how do you feel? Do you feel like your world is doomed? Should we do a poll? Let's do a little poll just so that I can see if I should just rehash again, draw something. Let's do a poll. Hang on. Okay. Let's see where we're at. Just going on past experiences of what is happening is the middle ground. It's the I wish I was not here, but I'm here and I don't know what's going on. I mean, 36% are feeling great, which I'm pretty happy with. Only 42% don't quite understand what is happening to them. They're having an out-of-body experience. Okay. Okay. Let's do what's the point of pointers? Who can tell me what's the point of pointers? I shouldn't say that too much. I will get it wrong. The point of pointers. Is it going to get worse than this? It always has to get worse before it gets better. I'll just put it that way. Efficiency. Yes, love that. Modifying data at the source. Yes, to point at something. Absolutely, just like I'm doing right now, but you can't see my hand because I made the circle too small. In functions, yes, it is such a great thing to use in functions. Are they like global variables but better? Kind of, yeah. I mean, a lot, yeah. You can also do some serious damage because you're modifying things directly at the source. So They aren't pointless. No, job interviews. Yes, pointers. Yes, very important for job interviews. Now, tell me, if you had a function, okay, and the function was to swap to, you wanted to have a function to swap two numbers around, okay? How would you do that with using no pointers? Okay. This is, I think, one of the most common I think this is one of the most common ways to demonstrate why we love pointers so much, just because some of the other things are quite hard to demonstrate so early on, like things like efficiency, things like saving memory and stuff, and also because we don't really care so much about wasting memory in 1511, not yet. You will start caring about wasting memory later on, and that's when all of these will kind of start coming together a little bit more. So if we have, let's do this piece of code, and this piece of code basically demonstrates how we can use pointers to help us get around being able to return only one thing, right, with functions. So what we're going to try and do is, if I've swapped two numbers, I can't return the two variables now to show what the two new values are. I could only return one of them. And then what, I don't know, hope for the best. So pointers allow us to kind of go around that and not have that issue, because we will modify something directly at the address of that variable, which means we don't really have to return anything because we're modifying directly at the address wherever we're actually doing things. So what would the function, if we were to write a function that uses pointers that is going to swap two numbers around that are passed to it, what do you think would be the input for that function? You don't need pointers for assignment 1. You can do it without pointers. You will need pointers for assignment 2. But don't worry, you will be able to use them by then. Two numbers. That's fantastic. I agree. Now, I want to give it two numbers, but do I want to give it two numbers, or do I want to give it two pointers so that I can modify those two numbers without needing to then return anything? Yeah. So what I want to actually give it as input is two pointers, two ints. And what do you think is going to be the output of the function if I am modifying things directly at their addresses? And that's about it. What do you reckon? What do you think I'll be outputting? Yeah, I won't need to output anything. It's going to be a magical function that will not require me to do anything. Now void, and I'm going to call it swap because, yep, swap. And I'm going to have two pointers, int number 1 and int number 2. So one is going to be oh my gosh, struggling. One is going to be pointing to the first number, one is going to be pointing to the second number. Okay, I saw someone early in the chat was like, so the swap is like a really common thing. And I always think, like, if you've never seen two numbers being swapped before, it kind of, it throws you a little bit. But I always think about it, think you've got a glass of milk and a glass of water, and you want to swap the glass of milk into the glass of water and the glass of water into the glass of milk. How do you do it? Without drinking one of the glasses and then spitting it out. Ew. It's disgusting. I don't know why I said that. Third cup. Yes, you need a third cup. Unless you do what I said, which was gross. Yeah. So we want something temporary, like a temporary little glass to hold our either glass of milk or glass of water. So I'm going to have a temporary in temp, and what I'm going to put inside that third glass that I've just created is one of the numbers. Doesn't matter which one. And what I've done is I've used that star, okay, which means it means go to the address. So that star means go to the address of whatever is stored inside this pointer and grab what's in it. So it's actually going to grab the value that's stored there, right? Okay, so that means in the third glass is now sitting number 1, and number 1 is now empty. So I'm going to use number 1 to put something else in it, and I'm going to put number 2 in it. And now I'm ready to pour out whatever was in my third glass into that second glass. So number 2 is now going to get whatever was sitting inside temp. So all right. So star, 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 lots of stars. That star is dereferencing it, which means that it's going to the address of whatever is stored inside this variable, and it's picking it out. So I'm going to actually bring out a pen, and I'm going to write down what this code is doing in a second, okay? Like I'm going to trace it by hand as though I'm a computer. And I hope that that helps you to, and don't question my bad writing in a second. Okay, so I'm going to run this program, let's say, and I'm going to call the function. I'm going to call the function swap, and I'm going to give it, what do I give it? Since I've given it two pointers, right? If I've given it 2 pointers, that means I can't give it number 1 and number 2, because if I give it number 1 and number 2, what I've given it is 2 numbers. I need to give it 2 pointers, which means I need to give it the address of, because a pointer is just an address of something. Okay, so let's see what happens here. Where's my pen? Here's my pen. Okay, so let's start running. We start running the program. We're the computer. We're reading through. Oh, black. That's really unhelpful in this dark. Okay, let's go here. So we're over here now. We've entered into the main function, and we've gone, okay, int number 1 is equal to 5. Great. I'm creating the first. I'm just going to do this. I'm sorry. I'm creating the first variable, number 1, and I'm assigning the value 5 to it. Now remember that this variable also has some address, okay? I'm going to make it up, and I'm just going to make a fake address. It's going to be 0xAA. Okay, great. Then I go to line 11, and I'm going to got number 2. Okay, so my second variable is number 2, so I've created another variable, number 2. I've assigned the value 10 to it. And it's going to have its own address as well. Remember, these addresses are completely made up. I'm just making them up to make it easier to then do what I need to do. So completely made up addresses. Okay, great. I've got a printf function, so I'm going to print out before swap, and I've got a printf function. I'm going to print out number 1 is equal to, that's going to be 5, number 2 is equal to 10. So that's what it's going to say. Perfect. And now I'm going to go to line 18, and I'm going to call the function, and I'm going to give it 2 things. I'm going to give it the address of number 1 and the address of number 2. So the address of number 1 is 0xAAA, and the address of number 2 is 0xBBB. Okay? So I'm going to go down to my function swap, and now I'm going to use this function. So if you remember, I've passed it 2 addresses. This first address that I passed it was 0xAA, and the second address that I passed it was 0xBBB. So that's what I gave this function to work with. I really should have just given them one letter addresses. I don't know what I was thinking. Great. So now we've entered into this function and we go into line 32 and we create another variable. So now this is my next function over here, and the variable is called temp. And what temp gets assigned is it's saying, okay, I want number one, whatever is stored inside, and dereference it. Okay, so number one from here is this 0xAAA. So that means go to this address. So I'll go to this address and find out what's in it. Okay, number 5 is in this address, which means that I'm assigning temp with number 5. Great. Then I'll go down to here and I'll say, okay, on the left side, we'll perform the right side first. So the right side, dereference number 2. So that means go to this address and find out what's in it. So I'll go to 0xBBB. What's in it? Number 10 is in it. So that's going to be 10. And then assign it to dereference to number 1, to the pointer number 1. So okay, so dereference number 1, and assign it the value 10. So I'm going to dereference what's at number 1, and I'm going to assign it the value 10. So that's now going to get the value 10. And then I'm going to go down to line 34, and I'm going to dereference number 2, which is this one here, because that was the one that I passed it. And I'm going to assign it the value that's in temp. So I'm going to go to temp. Temp is 5, and then dereference it in here. Dereference 0xBB, go to that address, and then I'm going to assign it the value 5. Okay, fantastic. So now we have swapped functions. I'll just erase this so it doesn't look messy. And we'll go back up here and we'll print out after the swap, and then we're going to print out the numbers again. But this time number 1 has the value 10 in it instead, and number 2 has the value 5 in it instead. And we did it all without modifying the variables themselves. We did it all by just going to their addresses and by modifying whatever is stored at that address. So when we dereference a pointer, we go to the address that is stored in that pointer. Okay, so let's compile it. Oh, forgot to save it. Okay, what does this error mean? Who remembers that? Yeah, fantastic. I forgot my function prototype. Okay, perfect. Let's try it again. And let's run it. All right, so before the swap, we've got number 1 is 5 and 10, and after the swap, they've swapped around to 10 and 5. So how do we feel? Have we changed how we feel? Can you change the way you, if you've done the poll, can you change? So you don't need to return both values. You don't need to return them at all because you've made the changes at the memory address. You've made the changes directly at the source, basically. No revoting. Thank you. I'll end this. Oh, someone was asking without pointers. What makes it very difficult, doesn't it? It makes it a lot easier to do it with pointers because then you can just modify it all within and then it's done. Otherwise, you have to kind of either stick things in main, which we don't want to do, We want, and you'll see if we do multi-file projects today, you'll see that we want our main to be just the running, the call outs to the functions. And then we want the functions to be doing everything else. Yeah, so dereferencing is going to the address of whatever is sitting inside that inside the pointer. Okay, so the pointer stores an address. Dereferencing says go to that address and get what is in that address. Okay, so it's like house numbers, right? So if you go to my house number, you will find that I'm sitting in my house. That was probably the worst explanation I've ever given. I could do better than that, and I will. Don't worry. Okay. So okay. I was going to do another poll. Another poll, quick poll. I really do want you to like get the bases of pointers, because then we okay. And where are we at? So the reason I'm not declaring a pointer is because I haven't used up, like, the pointer is, I've just given it my the addresses of these two things. And so the pointer is in here, right? I've used the pointers. I haven't used any new pointers that I need to declare. I've basically used pointers that are already there. I do, you know, when you use pointers, it is so much more clearer than, it's because I have to say the address off to the address off to the address off, and then you start losing me at one of those addresses. It does become better. And then when we do, when we get to linked lists, you'll be pros-ish at pointers. Okay. I was going to decay some arrays next. I don't know if I want to do that yet. I don't think we're ready for that yet. Okay, a bit better is better than nothing. All right, let's talk about a few more things then. We will do many more examples, don't worry. I could do another simple example, then take a break, then talk about the other stuff. Then we can just do multi-files at the start of week 7. Yeah, let's do that. Let's do just a random example, because why not? I know pointers, but you know, like, they're not, no one gets pointers to start with, right? Pointers will not be in the week. You will not do pointers until later. I just wanted you to, and there's no problem set in week 6. And you will have some pointers in week 7 to play with. Yeah. So so you can focus on assignment 1. You don't have to think about them, but I just want them to be on the, in the background, kind of making connections, because it's much easier. Okay. Let's do, what should we do? Someone give me something they want to do. Anyone? Anyone? Should we just do something very, very simple just to show a pointer again? Yes, no, maybe? Is there a delay? There must be a delay. I was not coughing this much the whole day. I don't know what's going on. Something simple. I just have to remember what I want. Well, I have to think what I want to do. Just the same people saying yes. I appreciate that. Okay. All right, let's, and I'll just comment through the code so that you can see what on earth is going on, and so that I can have time to make up something in my mind to do. So let's declare a pointer. And so when I worked in this one place, because I don't have to, I can just call it this, right? And when I worked in this one particular place, the style guide was always to finish pointers with the word PTR at the back, and I've really kept doing that for a very long time since I've left that job. Okay, let's say I'm going to leave it empty for now, okay? And let's do an int my variable. Let's give it a value. What should we do with it? Oh, what about if we, yes, I know what we're going to do. We're not going to declare a pointer. Okay. Okay, let's say we're going to declare a variable. Let me know if this was too simple and that you wanted to do something more. Then we're going to call out to a function and modify this variable by multiplying it by 5. Why not? I'm really making this up as I go. Okay, so great. So let's call this function multiply 5. And let's do some printf statements so we can see what's happening. So we'll do first one, this one, and we're going to call it my variable. And then we'll do multiply 5. What do you think we're going to send it to? If we're going to do, I want to do it directly, you know what? I'm going to send it the address of my variable because I want to do it directly in memory, okay? So what I've done is I've sent it the address of my variable. So wherever this thing is stored in the computer memory, I've sent it that address. And then I'm going to print out this again to show what is stored in there. And returns 0. Okay, let's do a quick function. Now this function, genius function, multiplies by 5. Okay, so function was called, will the function return anything? What do we reckon? No, I won't return anything. I'm just going to do it at the memory address. Don't need to return a thing. So it's going to be a void function. And the function is called multiply 5. And it receives a memory address, which means that it receives a pointer to an int. Okay? So int star, I can call it pointer. It doesn't matter what I call it. Because all that's going to sit in there is going to be the address of this, okay? And we can do, I'll ask you if you want me to do it, to run through it like I'm the computer. You know what, I'm going to start that poll now so that I can. Okay, and we're just going to multiply it by 5, which means I'm going to return to it. What will I return to it? How will I multiply this pointer by 5? So I'll need to dereference it before it, well, I can do just that to start with. And I'll need to dereference my pointer. Yep. So I'm going to dereference it by doing that, which is saying go to the address that is inside this pointer and then multiply whatever is sitting in that address by 5. All right, should we see what it does? And then, oh God, I did not mean to do that. I just almost ended the stream instead of not trying to save here. So let's run it, and then I'm going to do it by hand as well so that you can see what's going on. And it's simple enough to not take up a lot of time. So let's do DCC. Every time. Oh, and then I copied it and pasted it as well. So remember, I don't need to return anything if I'm modifying straight at the source, right? And of course, I forget the function prototype every time. You could write a novel and be consistent in the type of errors I make. At least they're easy to fix, I suppose. So there's no return value because, yeah. Good chat, good chat. Yeah, I see what all of you are saying. My God, it's a struggle town here, isn't it? Okay, so I'm just going to modify my pointer, and what's going to actually, this is, yeah, what's going to happen here? Do you reckon this is all good? Have I killed you all? Or not yet? Just slowly. It's a week 5 type of vibe. Yeah? I don't know if that feels correct. 260, yeah, that's correct. So it's not making it a global variable. I don't want you to kind of think about it like that, because there are issues with global variables, and they can be quite dangerous. It's not the same. Working with memory is not the same as using global variables. You can have the same access to things overall, hypothetically, because you have access throughout the whole thing. But there are big differences, right? Okay, so let's do a quick run through of the code just so that you can see what's what. And then we're going to take a little break because I've fried you. Okay, quick run through. Here we are. Okay, so first things first, we enter into main and we create this int my again, I'm just gonna, okay. I'm gonna call it my var, sorry. Okay, so I've created this variable and the value of it is 53. I really couldn't have used any worse values if I tried. But this time I'm going to be smart, and the address of this here is going to be 0xa. Amazing. Okay, then I printed out my variable is equal to 53, and I thought I was absolutely amazing. And then I called out to multiply 5, and I gave it the address of my variable. So my variable, the address of it, so what I've passed to that function is 0xa. Okay, great. So I've gone down to my function, and what I took to my function is this address 0xa, which means that when this function runs, right, I've got this pointer variable, right? So a pointer variable, and this pointer variable is storing the address of 0xa. And don't forget, this one, it still has its own address, whatever that may be. Okay, 0x, don't care. We'll just call it B. So then when I go to this line here after I've entered the function, okay, so I always do the right side first. So the right side tells me go to whatever is stored inside pointer and dereference it. So first of all, what's inside pointer? Inside pointer is 0xa. Go to this address. Okay, I've gone to this address and find out what's in it. In it is the number 53. So the result of this bit here is actually going to be 53. And it's going to say, okay, 53 times 5. It's equal to 265. So now take that 265 and assign it to your pointer. Okay, so assign it to whatever's sitting there. So which means that it's just going to assign it. So go to pointer, the address stored in there, 0xa, dereference it, which means have access to be able to write it. And then we're going to write it in here. So now it's 265. And I'm going to finish the function and I'm going to return to where the call was made. And note that I haven't even stored the return, and I don't need to store the return anywhere because it's already in memory. I modified it in my memory. So when I call my next printf and I print out the value of my variable, it's going to go to my variable and it's going to grab the value 265 and then it's going to print it out here. Okay. How are we feeling? Can you just write down yes or no? It's all coming together. That's what I like to hear. Fantastic. Let's take a 5-minute break because then it's all going to fall apart again for a little bit and then it's going to come back together again. Okay. But it will. Yeah, it will come together. I promise. And then it will fall apart again and then we'll come together again. So let's have a little break, 5 minutes, and then we'll be back. Let's do 7 minutes. So 3:10 we'll come back at. And we're going to do, I don't have a Kahoot right now, but I have a Kahoot for command line arguments that we're going to start with next, after the break. Okay, a little break. Where's my OBS? glad I had that conversation with the microphone off. That was really exciting. Good stuff. That was really, yeah, that was excellent. So I said, Jake did the Kahoot I wanted to do today, but then we're not ready for the pointers one yet because there's still a few more things to cover with pointers. So we're going to do a little bit more pointers, and then we're going to do the Kahoot. Okay, does that sound good? Even if it doesn't, that's what's happening. Sorry. No, you're not going to be marked for efficiency in assignment 1 or assignment 2 for that matter. 1511 really lets you get away with crabby efficiency, because when you're learning to code, you don't write efficient code usually to start with, and then you start picking up how to get more efficient. Yeah. Lots of good style, lots of good lots of good style, and lots of functions are a part of that. So in some ways, you know, efficiency is a part of that, you know, breaking things up into functions. Yeah, there is a rubric as well that you can see on the assessment for the assignment, so that you can actually see what's going on as well. Don't be scared. No one should be scared. I mean, I don't know, maybe a little bit scared, but not super scared, just a little bit scared. I tried to like do this big thing to show you how memory works. I don't even know if I have time for it, to tell you the truth. I don't know if I should rush it or if I should just move on and talk a little bit more about and yeah, let's just continue our it's so pretty, isn't it? No, okay, you know what? I'm gonna do it if we have time to talk about scope. Or should I do it now? The indecision, it's been too long. I'm gonna do it quickly. I don't want to waste this beautiful, pretty thing. Okay, let's talk a little bit about memory. Okay, so we've got the stack and the heap. We have been doing a lot with the stack. We have been doing nothing on the heap. Okay, so we have had someone else do all of our memory management for us. Not us. We have not had such powers yet. We will soon have such powers, and great power comes great responsibility. This is where things go down, very much so. Yeah, what was that? The CrowdStrike, wasn't it? That was one of these mistakes. Anyway, okay, so stack, heap. Stack is happening as we when we run our program. Anything, you know, variables that we declare, they all go on the stack, which means they kind of get organized to where they go. We tell the computer how much space we need in advance, so that space is given, and that's why it can go on this stack, and that's why it's kind of sitting in there. So let's it keeps all of our variables, it keeps function calls as well there. So then it kind of it progresses through what on earth is happening, right? So once that block of code finishes, so once those curly braces close, everything is removed from the stack, right? So that was between those curly braces, right? So that's what I mean about the scope of a variable. It lives between the curly braces. After that, it gets removed from the stack. And that's because you're not controlling the stack, and the computer is being efficient by giving itself some memory back, because otherwise, if you just keep not removing anything from the memory, at some stage you're going to overflow that memory, because if you just keep adding to it and adding to it. So like that TV show Hoarders, which I do enjoy sometimes. Okay, that was not meant to come out. Okay, so at compile time, the stack space is allocated, right? So not at runtime. So once the program is running, you cannot do anything. You're done. Your work is done. And if you are short of space, that's your problem. You can't actually do anything there. And that's why we kind of need the heap as well. So the stack is controlled by the program, not by you. So let's have an example, okay? So in the example, we've got our main function and we've got a sum function. So basically what's happening is I'm going to declare a number, I'm going to declare a second number, third number, I'm going to declare a pointer because why not? And then I'm going to call a function and then I'm going to see what's going on, okay? And this is how things live and die. I don't know why I keep saying live and die. This is how your variables make their way through the calls and the stack and how. So main is called, first port of call, and that means the call to main goes on the stack. Then I declare an int number and it goes on the stack as well because it's telling me it's int. I know exactly how much space it needs because I know how much space an integer takes up. Then I do declare and initialize another variable, number 2, and I assign the number 5 to it, and it goes on the stack as well. Fantastic. Then I do a third one, and again, number 3, it goes on the stack, and I assign the value -1 to it. Okay, then I declare a pointer here, so a pointer that's pointing to an int, and it's called number pointer, so that number pointer goes on the stack, and it's got the address of number 2. So it is pointing to the address of what's sitting inside this number 2. Okay. So the next thing happens. Remember, we do the right side first, which means that we make the call to sum now. So that call goes on the stack, and that means we enter into this int sum, which does not take anything. So inside int sum, I'm going to get an int number. Now, this int number is not the same as this int number, okay? They are two different variables. This number is living only in the sum, in between these two curly braces. So this int number is declared and it is assigned the value 10. So I've got the value 10 here. Oh, shouldn't have. And then the next line here, it takes that number and it adds 5 to it, which changes that 10 to a 15. Okay. And now it says, okay, return number, return to where, return back to sender at this point. So it gets to the end of that, it returns number, it gets to the curly braces, and you note that all of this sum business is taken off the stack. So all of these variables are gone now, and so is the function call to sum, because we return back to the place of where we started from. So we return number, which means that this thing here now has 15. Yeah, 15 has been returned, and it's assigned to the variable number 4, which means that number 4 goes on the stack now, and it's assigned the value 15. Okay, great. So what happens next? Next, we're going to go to return 0, and when we hit that beautiful curly brace, we're going to get rid of all of those fantastic variables that we had before, right? So they're all gone, okay? So remember, again, a variable that you declare inside a function is only inside that function, right? Unless you're doing a pointer and you're modifying something at the address, then that carries through. But as soon as we close this main, we got rid of all of this and we've cleared the memory. Well, not we, the program did, not us. We're not controlling this type of memory. We don't control the stack. Okay, so far we've only talked about things that are on the stack. And everything in the stack lives between those two little curly braces, which is, you know, yep. And that means that if we create something inside a function, it will die in that function as well, unless we return it, or unless we have pointers that we kind of pass, you know, do the manipulation in. So it is really useful. So like, think of this function here, right? If I have a function that creates an array, Okay, so like I haven't created an array inside of my main. I'm going to call out to a function called create array. And I've got this create array, fantastic. I create an array, it's called numbers, there's 10 elements in it, they're all initialized to 0. And then I'm going to return the pointer to the array. So I'll return this numbers and we'll talk about the array and the pointer soon. But when I close the curly brackets, the array is killed, right? So this thing here is killed, which means that we are returning a pointer to memory that we no longer have, right? So this memory over here is going to be cleared when this function is closed. So when you return a pointer to this memory, you're not going to be able to actually return anything, right? So it's going to be quite a dangerous thing to do. And that's why we have this wonderful thing called the heap. Now, the heap is another place in the memory where we, why are people so taken with global variables? Don't use them, especially not in foundational programming. They are really easy to make mistakes with, and huge issues have been had with global variables and bugs that are not very easy to find. So the heap. Okay, so unlike the stack, we control the heap. So it means that we allocate memory on the heap, and we also have to deallocate that memory. So if we've given memory, we need to clean it out as well. Okay, so we need to be able to both give memory and take it away as well at the end, because otherwise if we keep giving memory, then we're going to flood the heap with, you know, ridiculous waste of memory. Okay, so how do we allocate some memory? There is a function. How amazing, of course there is. And it's called malloc, memory allocation. It even makes sense the way, it, you know, beautiful. So this function malloc, memory allocation, it lets us give some memory, allocate some memory, and it lets us decide how many bytes of memory we want, and what we get is we get a pointer to that chunk of memory that's been allocated. So let's do some malloc and see what it does. Malloc does have a cousin, and the cousin's name is free, and malloc cannot go without free. Okay, so malloc is how we would allocate the memory, and free is how we deallocate the memory. So whatever memory you make, you have to free it at the end of your usage. Okay, if you do not free the memory, okay, you're going to get some issues, right? You're going to slow things down. You're going to create what is called a memory leak. Now, what is more dangerous is that memory leaks are very easily exploited. They're a vulnerability for security, and we will talk about that as well as we go on, not today. So we don't want memory leaks. Memory leaks are bad. And in assignment 2, you will be checking a lot for memory leaks, and you will get to see memory leaks a lot. And that's really good, because we want you to learn what a memory leak looks like and why we want to plug it up and why we don't want memory leaks. So we use free always to deallocate any memory that we made with malloc, okay? You don't need to use free for a pointer that you created. That's not memory that you made. A pointer's still on the stack, right? A pointer is still a variable that I've declared. It's a variable that I know everything about. But memory that I have allocated, so a memory that I have used malloc for, so the pointer that points to that memory, that is memory that I need to free. So anything that I've created myself, I need to free it up as well. Okay, so I said, okay, malloc is amazing because malloc is, you know, it lets us allocate some memory, but I need to be able to know how much memory I need to allocate, right? I can't just say, just give me memory, either guess how much I want, or, you know, I don't know, just give me all the memory because I'm greedy. So we use this sizeof function. So today you're going to learn three things that you will do with memory, or three functions, and they're going to be malloc, sizeof, and free. Okay, so there are three things that that kind of come together to allow us to allocate and deallocate memory. So sizeof allows us so sizeof isn't just the standard library, but malloc and free will be, yes, we will use another library and in a second. Let's do sizeof first, just so that we can see what we need for malloc, and then we'll go to malloc, and that's when we'll do the standard library. But that's a very good question. Okay, so I haven't really, I just left this code up here for you just so that you can see what it does. Okay, so what I've done here is I've declared an array as an example, and this array has 10 elements in it. It's just initialized for everything to be 0. Okay, now you'll see I'm using another format specifier, which is killing you today. Don't worry about it. You will never really, well, not in 1511, you will not need to use this percent specifier, but sizeof returns an unsigned long int, and so I'm using a %lu to give the return of whatever sizeof comes back with, so that you can see what it's doing. So if I compile sizeof, and all it is, you see this function is sizeof and then just whatever I want to size off. Okay, so here I've done the size of an int is something bytes, and all I've done is sizeof, and then I want a size of an int, so I'm going to say size of 1 int. Okay, so if I run it now, any day now, I'll type the right letters. Okay, so let's have a look. So the size of 1 int over here is 4 bytes, yeah, which we know to be true. Then I want the size of an array of ints is something bytes, and here I have size of the array. The array has 10 elements in it, and each one is 4 bytes, which means that the whole of array is going to be 40 bytes, yeah. Now the size of 10 ints is 10 times size of an int. So I can do something like this as well, right? And again, it's going to give me 40 bytes because I've just multiplied 10 by the size of 1 int. Size of a double, I'll use the sizeof, and then I'll use the keyword double, and it's going to give me 8 bytes. And the same thing for a size of a char. It's going to give me a size of a char is 1 byte, which I also know to be true. Okay. So sizeof basically gives me a size of whatever it is that I need, and it will allow me to malloc or allocate as much memory as I want precisely by using this sizeof function with it. Okay, excellent. So let's have a look at now using this malloc lovely thing for us. Oh, I've got a really... Was this the example? Yes, this was the example I wanted to use. Okay. So we're going to use malloc, and we're going to use free now, and we're going to use sizeof in a second as well. Okay, so this program gives an example of how you can allocate memory for an array and then read in the array and print it out in reverse order. I don't know why. We could have just printed out in normal order. I don't know why I have to make things complicated sometimes. Oh, I do just normal array, and I do no. Okay. So let's have a look. All right, so usually, you know, we'll have an array, and that array is going to have, we say straight away, that array, I want that array to have 10 elements. So normally what we would do is we would declare an int numbers, and we will say how many elements there are. Now, if I don't know how many things I want to store in my array, usually I'll give it a really large number. Like I'll say, okay, well, I don't know how many things are going to be in there, so I'm just going to go, give me 3,000 elements of that array. Okay, so fantastic. That's going to create 3,000, and then I run the program, and let's say I only use 3 things, right? 3 out of 3,000. That's not very efficient at all. So that's a little bit rubbish. So what about if I allocate memory to that array by finding out first how many elements there are? Okay, so that means I'm going to allocate memory at runtime, not at compile time. Okay, let's have a look. So I'm going to get rid of this. And we're now going to have something called insize, just a normal variable. We're going to print out how many numbers would you like to scan in, and then we're going to take in whatever the person wants to scan in. And let's say the size is 3. It doesn't matter what the size is, but we will use it afterwards to, if we want to run through it, for me to hand execute the codes. Okay, so I want to allocate some memory space for the array to store the number of elements. And then what I want to do is when I use malloc, it returns to me a pointer to the first element. So the syntax of malloc, or how we use malloc, is this. So int pointer. So this is the pointer that it returns. So the address of whatever memory you've created is stored inside this variable here. Then I use the function malloc, and here I used sizeof to tell me how much size I want to be able to actually malloc. So what am I actually looking for? And I'm going to include the library standard library.h, so stdlib.h, which is where malloc and free live. Okay, so that's the library that's going to allow us to use malloc and free. So new library, standard library.h, stdlib.h. Okay, so let's do it. So I'm going to declare a pointer, and it's where I'm going to stay. So I'm going to say my array, and it's where I'm going to store the address of the memory that it's created, right? Because otherwise, if I malloc some memory, I have no way to know where that memory is, because on the heap, the memory is not organized. It just kind of picks out a little bit that's empty and gives me that piece of memory, which is a really weird way to think about it. A heap is like, just think of like a floor drobe, you know, all your stuff thrown on the floor, and then you kind of have to poke around a bit. You don't actually, so I want to know where to find that particular item that I've created, the particular memory that I've just allocated, which is why I'm storing it inside this pointer. Okay, then I'm going to use malloc, and you don't need any of this for assignment 1. This is going to become relevant for assignment 2. I would not torture you by actually giving you new information for assignment 1 in week 5 to use in week 6. I do want you to get some sleep in week 6, not just kind of stay up hating your life the whole time. And don't worry, by the second assignment, I reckon second assignment is easier than the first assignment, especially stage 4. Okay, so malloc, and then we want to we want to be able to so sizeof and int, and here we stored into size the number of things that we want. Okay, so what I can do is I can just do size times sizeof int. So what that will give me is whatever people entered, however many elements they want to do. Okay, we're going to multiply it by a size of 1 int. Okay. All right, so whatever memory I've just created is going to go into this myArray pointer and be stored in there. Now, not likely at your, in 1511, right? Not likely. But as you move further on, it's also very good practice when you malloc some memory, so when you allocate some memory, to check whether there is enough memory to allocate, right? So that it's not, otherwise this will create nothing, right? And you will have a null, and then you'll have a whole bunch of issues that you don't want to have. So to check that there is enough memory to allocate, what we do is we're going to check if this fails to create the memory, to allocate memory, it will return a null, okay? So when it fails to allocate memory, or there's not enough memory to allocate, it will return a null. And that means inside this pointer is going to be a null address, okay? So I'm going to check whether or not inside this myArray pointer, I have a null address. So I'm going to check if it's a null. And if it is, then I'm going to say there's not enough memory to allocate, and I'm going to return 1 and exit the program. Okay. Okay, so now let's perform some functions. So I'm going to read in the array, and I'm going to send it the pointer. So I'm going to send it my array pointer, and I'm going to send it the size as well. Okay, because just because I've sent it this my array pointer, what this has is it has the address to the very first element. Okay, so it doesn't have, so it has the starting address. So let's say this malloc 3 times 4, 12 bytes of memory. Okay, you've sent it the pointer to that first section of memory, not to the whole thing, right? So you don't know how long that whole thing is just by looking at this. So you need that size. Okay, so let's go to this read array. Read array, where's read array? Read array reads in here. Okay, so what do we think if we're to read in an array? Then we're going to have, I guess, well, it's kind of giving away what we've sent it an address because we sent it a pointer. So we've sent it a pointer and we've sent it a size. Okay, so that means the input is going to be a pointer and a size, so an int, and the output is going to be nothing because all we're doing is reading in. Okay, so void read array, which was the function name, and it's going to be a pointer and size. Okay, and remember that this size here, even though I've called it the same, is now, it's not the same as the size over here that I've sent it, right? It's a copy of it. And it's a copy of it that only exists inside this read array function. Okay, and what I'm doing is I want to just constantly scan in and be able to ask someone for numbers. So I'm going to use a for loop and just your normal reading in through the array. So whilst I is less than size, I'm going to I++ and then I'm going to scan that number into my array. So I'm going to scan a %d and I'm going to scan it into my, so the array is numbers, and you'll see that, you know, that doesn't look like an array because it doesn't have the square brackets at the end. And that's where I'm going to run out of time to do it today, but that's where that whole array decays to a pointer comes into the picture, because when you, yeah, so we will do that in a second. So just trust me that this is kind of the same thing for now, and we will go over it in week 7. Okay, so we'll scan it through and that will read our array for us, hopefully. And then I want to print it out just to make sure that it's working. So again, to print it out, I'm just going to send it the address and the size yet again. So to print it out, the same thing as before. For the input, I would need a pointer and an int. And for the output, I would give nothing back because I'm just printing stuff out. Okay, so let's do print array, and same thing as before, just a pointer and the size. And again, we're just going to have a for loop to scan through the whole array and to print out each element of the array. I'm slowly, I think, dying here. Size I++ to increase it, and let's print out, let's do numbers, and whatever is stored inside here is going to be equal to whatever we're going to put in, and then we're going to do that. Okay, how does that look? who's been following me along. Don't worry, I'm going to run through the code as well. I should have really picked something more simple to demonstrate malloc to start with, but I did not. I really thought we had all the time in the world. I don't know how time goes so fast. Okay, I'm going to just run through it. Let's DCC and then we will run through it just by doing the code by hand. Should I do that? Let me do a poll whilst I do that. Okay, let's compile it. And how ironic, I called it memory fun as well. It's like I'm trolling you all. Happy Flex Week. How many of those do you think I forget? Where did I forget it? 31. Don't forget my prototypes. Good, good, good. Oh, they're already here. I forgot to delete them. Fantastic. Okay, and what have I done now? Oh, I've used one equal sign and no one picked it up. No one in the chat even said anything. One equal sign to assign, 2 for equality. You guys asleep? What's happening? Oh, and then let's not free anything for now. Danger. Okay. How many numbers? 3. Okay. So 3 numbers. It called out and it typed them all out. Okay. Amazing. So now what I was saying, so malloc has allocated memory on the heap, not on the stack. So when we ran through those boxes before, that's not where that memory is. Malloc cooked you. I'm so sorry. Malloc is very special. Malloc, and this is what I mean, like you'll be cooked and then you'll be okay. You'll be cooked and then you'll be okay. You'll be cooked and then you'll be okay. It's because it's all so new. Okay. So don't think you have to be absolutely, you have to get it right now. Okay. It will come together in like 3, 4, 5 times that you use it. Okay. I promise you. And that Kahoot is also going to have, so malloc allocates the memory that you want and returns to you the pointer to the address of that memory that it allocated. Okay. So 342, my God, what is happening? Why? Yeah. Okay. Let's do it. Let's do it. Let's do it. No, I will not. I will not. Okay. We're going to run through it. It looks like everyone wants the code to be hand done. Okay. So first things first, we go into main, we create this size, and size doesn't have a value yet. Size also has very bad handwriting, and size has some memory, don't know where, don't care, but it's got its own memory address. Okay, so the variable, and it's on the stack. Okay, so this is our stack. This is where things are made by the program at compile time. Okay, print out how many that, then we scan a number in. Okay, so let's say we're going to scan the number 3. Okay, so we're going to go to the address of size. The address is 0xa, and we're going to scan in the number 3. So we're going to pop a 3 in. Okay, fantastic. And now we're going to do something else. We're going to malloc some memory. Woo! Okay, and that memory is going to be on the heap. So we are asking to allocate memory. Size is equal to 3. This size of int is 4. So we're asking for 12 bytes in total. Okay, so we wanted to go on the heap somewhere and get me 12 bytes. Let's say this is 12 bytes. I want these 12 bytes of space, please. And they can be anywhere on that heap. It doesn't have to be, you know, sequential or anything like that. It's a mess. It's like my floor robe. Which I shouldn't have because I'm too old to have a floor robe. Okay, and then that means I have no way of knowing where this 12 bytes is. Where does it start? Where does it end? It's somewhere on the heap. It's somewhere in my pile of clothes. Don't know where it is. So that means I want the address of that. So this 12 bytes of memory, wherever I've created it, the start of it over here, let's say at 0xz. Okay. So that's now going to go into this my array pointer. So this my array pointer now stores that address. I don't know why I wrote it down here. Don't question it. I'm trying to find like a good space so that you can see what it's got. And it shouldn't be, oh, that's a complete mistake to write it there. I want it moved. Okay. Because I didn't create enough space to write it elsewhere, and I should have. So this my array pointer, pretend that it's here. Is going to have this address in it now. So 0xz. And it's a pointer. Okay, excellent. Good. So now we move along and we check if it's null. Okay, so this part here, this part here will check whether or not this is equal to null. If my array pointer is equal to null, well, it's not. It's got an address in it, which means it's not equal to null. So I'm going to skip over this if statement. I don't need to go into it. And I'll make a call. I'm going to call this read array function. Okay, I call read array function and I give it my array pointer. So inside this my array pointer is 0xz, which means I give it this 0xz. I give it that address and I give it the size, which is 3. So those are the two things that I'm sending off. I'm sending this function off with. So I'll go down to read array and, oh, that was perfect. Just appreciate that lining up. Amazing. Okay, I'm just going to get rid of that. So I've gone here, and that means that my int numbers now, which I'll create as part of this function, this pointer numbers, is now going to have the address 0xz. And actually this size, what I was saying to you before, is different. So this size is now in the function read array. So this size is different to the other one, and it's got the number 3 in it as well. Okay. Okay, great. So now I go into this loop and I go for int I is equal to 0, which means I've now created a variable called I, and I've assigned the value 0 to it until it's less than size. So until it's less than 3, I'm going to keep adding 1. Enter a number. I'm going to enter 1, 2, 3 like I did before. Let's pretend. So now into numbers at index I, so at index 0, I'm going to place, and that means I have the address of numbers, which means I'm able to know where it is. So into the first element of numbers, I'm going to place 1, which means that it's going to, so I don't have any space to write it, but at this, okay, let's say it's 1, 2, 3. So at this point here, it's going to get the number 1 allocated to it. Then we're going to run through the loop again. I'm going to get the number 2 in it. I'm going to run through the loop again. I'm going to get the number 3 in it. Okay. Then this is going to finish. Okay. And once it finishes, this is gone, this is gone, and this is gone. Okay. They're all now dead. Okay, fantastic, great. Then I'm going to rush back up to where my call was made from. Hello, lovely. And I'm going to do the next call, print array. And I'm sending it my array pointer, which is 0xz, and the size, which is still 3. Excellent. Oh, well, that was good timing for that. I'm going to go back down to here into my call, okay? And this call has numbers again, and that means I'm now creating that numbers again. Oh, this is much nicer writing. Why wasn't I doing this before? Okay, so it's creating this again as part of this function, and it's a different numbers now, but it stores the same value in it, 0xz. And the int size is created again, and the size is equal to 3. Okay, so fantastic. Then I go in it, I create an I is equal to 0. And I start running through the thing. So then I'll have numbers at, so that means at %d is equal to %d. So numbers at 0 is whatever is stored inside numbers I. So it's going to be my first element. So element 1. So it's going to print out the 1. Then it's going to iterate 2 and then iterate to 3 as well. Okay, so that kind of demonstrates how it runs through. Okay, so how does that feel? Does that kind of make sense? How the malloc was used to create this piece of memory? But now because okay, no, wait, I'm still going, because I'm going to show you why it is what's going on. So this function now finishes, which means all of this is gone. So this function finishes, that's now gone, that's now gone, that's now gone. Okay, fantastic. So we're going to climb back up. Okay, so we're going to go back to where the call was made, and then I am left with this chunk of memory that's still there, right? So I really want to be able to kill that memory that I've created on the heap. So this memory is still there and I want to get rid of it. Okay, so in this case it would happen on program exit anyway, but that's not, get used to freeing memory. So I'm going to free, and then I'm just going to say the name of that memory that I was like the name of the memory that I am storing my malloc in, basically. Okay, so the allocated memory. So I'm going to free everything that's stored in there, and then I'm going to return 0, and what that will do is that will kill off all of this. Ta-da! How are we feeling? How are we feeling? I'm going to stop this one. I'm going to see how we're feeling, and then we're going to do a Kahoot, I think. And the Kahoot, one of the questions we'll have to skip. Oh, I just wrote how are you feeling in the chat. That's you know what? That's the correct feeling. Feeling cooked is the correct feeling for this lecture. And it is really unfortunate that I had to come back, and this is the first lecture that I had to do, because I feel like you haven't seen me for a few weeks and I come back and this is what you get. Sorry. I promise it will come together. Yeah. I know it's all doom and gloom. Don't be doomy and gloomy. Week 6 is coming. That's the best week. Understanding a little bit is good. I promise it does get better. Who was that? Was that Bree? Thank you, Bree. So if you forget the free, you create a security vulnerability that can be exploited in the future. And we will talk about that in a second. So free is very, very important to free whatever malloc you do. That grammatically made no sense. I'm really cooked as well. Don't be worried about linked lists. I reckon pointers on their own, often like this to start with, don't make sense. Then when you do linked lists, pointers make so much more sense, okay? I think. Because we don't even do pointer arithmetic here, not till next course. You don't do it in 1511, so don't, you don't even have to worry. Pointer's still fun. Pointer's still fun. No, linked lists are actually, linked lists almost make more sense than arrays. Yeah, I did come back just to kill your hopes and dreams. Sorry. Should we do a quick Kahoot? Or will that hurt too much? Are we done? How are we feeling? Oh, I feel so, no, don't be cooked. Be sweet. All right, quick Kahoot, why not? Okay. Let me switch. This gives me time to erase. Yeah. Good chat. Yep. Doing really well with that erasing. I promise you, This is probably the worst of the worst. It will be better from now on. It was very unfortunate to have to come back to this lecture. You know, it's like long division in primary school. Teachers don't want to teach it because people hate it. That's how I feel right now. Oh, I kind of erased it. Future you will understand pointers. I promise you. You know, the first time I learned about pointers, I don't think I understood pointers for like a year properly. I was using them, but it was methodically. It was not with any understanding. Just to make you feel better. All right. Let's do it. Let's start. Oh no! Don't remove hope. This one's going to be like in fast. Everyone's going to be how confident. I hope it's not all red. Oh my god. I'm preparing myself. This is going to hurt. This is going to hurt. Is this going to hurt? Will it hurt? It will hurt. I know it will hurt. Oh, not too bad. A little bit. Very familiar. 11 people. Good for you. I hope that you can help those around you. And 25 moderately. Oh, I love that. And this is very nice. This is better than I expected. Good job. And for those of you that are very good with pointers, can you just in the chat tell people that they do take a while to get used to, but then they do come together? No one wants to admit now that they feel comfortable with pointers. You do, you so got this. And the best thing is you don't have to got this for the next week. You can pretend pointers don't exist for the next week. Oh, look at that. Just one person that thinks that it stores a number. No. So look at this. You all know what a pointer is. So this is a great one. Like this is great first step towards what's going on. Okay, who's coming on top? Big Gaming. CS is cooked. No, CS is the best. Brie, I thought you were putting up your hand that you were that one misclick. Okay, very good. Not bad at all. Okay. Symbol used to access the value stored at the address point by a pointer. So dereferencing. Okay. So the star is to dereference. The ampersand is address off. Okay. Let's see what's going on. Okay, nice. We've got, oh, CS is cooked is coming quite well. Let's see next. Oh, that is awful. Sorry. We didn't even do this. I didn't give you the beautiful decay of an array. Oh, well, I'll take a guess. You could, you know. No, it's still there. We didn't do this, so it's fine. That's what I'm saying. We didn't do this. We didn't do the array decay. Don't worry about it, okay? We will do this in the next lecture. Something to look forward to in week 7 when you're all refreshed after doing your assignment. No, I'm going to skip this one because we haven't done this yet either, okay? So I'm going to skip it so that people don't. We're going to skip this one. Oh, someone started to reply. Okay, and I think... Okay, last one. Let's go. We got this. Well, you've got this. Here we are. Here we are. Let's go. We've got this. Let's everyone. Let's have everyone correct. Almost everyone. Okay, so remember the and that you've been using since you've been using scanf. It gets the address of a variable. Yep. And the asterisk, the star, is to go to the address of and get the value there. Okay, so it's like and is the house, like the house address, and the star is what is inside that house. Okay. All right, here we are, number 3. A neutral person. D Doug. And I hope it's CS is cooked. No, Newsy! Woohoo! Yay! I wish I had chocolates to throw at you. This is why this lecture is better done in person, when I can give you like chocolates and stuff to keep you going. Anyway, I hope you all have a really nice flex week. I'm so sorry that we ended with pointers. But also enjoy not having to talk about them for a week. Have a lovely flex week. Good luck with the assignment. Please remember there's a lot of help sessions running. Please make sure that you've started the assignment. Use this week's labs to ask questions as well. Please. And help sessions are running through flex week as well. Okay, so please come and get help from us and get through the assignment. Please let us know if you need any help at all. We're here to help you. Good luck, and I look forward to seeing you on Monday in week 7. Bye, everyone.